Hey everyone, this is a high-level video showing the process of going from 2D in AutoCAD to 3D in Inventor, and then program our part with Inventor HSM, and then export that out into G-code. We can then cut this part on one of our CNC machines. So here we have a 2D drawing in AutoCAD, and this is all going to be done within the product design and manufacturing collection. And so this is a 2D drawing from a customer or from one of our colleagues. It doesn't have any dimensions on it. We're going to use this geometry. And I'm going to go ahead and open that into Inventor. So here I'm going to switch over, go to Inventor Professional. I'm going to do a brand new part file. And I'm going to import that 2D DWG into Inventor by picking a plane and a point as a reference to start. Here it's telling me I should save it. And then we get a message that says, just letting us know this is going to be associated with the 2D drawing, which is what we want. So we say OK there. Then we're going to go back and create a drawing on that same plane and use this project DWG geometry. I can then highlight the geometry I want, which is half the profile, and then come in and draw a line from the midpoint of the top to the midpoint of that bottom edge. Right click OK, right click, make that a center line, and then I can finish that sketch and come up here and do a revolve to turn this into 3D geometry around this axis. So I say OK, and there is our 3D model from that 2D geometry in AutoCAD. Next thing we're going to do is switch over to the CAM tab. So Inventor HM installs directly on top of Inventor and is associated. All the data is saved into that part file. So the first thing is to create a setup. This is where we define that this is a turning part. And we're going to reference that axis, put our G54 at the front of the stock. And then as far as stock, we got 1.5 inch diameter by 3 inch length. We'll say offset from front by 20 thou. Right click and say OK. Then we can go in and start adding operations. So maybe the first one would be to face this material. I'm going to come into my tool library, pick a tool, and they did a good job with defaults. It automatically goes to the front of that part. Then we can maybe do the same thing and do a profile on the outside with the same tool. So here it's going from front to back. I do want this to be rest machining so it recognizes that that front has already been machined. I also don't want it to try and go on the front, so we're just going to only allow radial grooving. We'll say OK there. So there's just a couple operations. You would need to groove that and maybe do a parting operation as well. But once you got a couple operations or the part is programmed, we can then run into simulation, show how that part's being cut. Once we verify the simulation looks good, we can compare it to the model by doing show part comparison, and here I can see where there would still be some material left to remove. Close that. Once it's done, the next step in the process would be to export that to G-code through our post processors. So this is posting out to a Haas. Here's all the G-code. You would then save that NC file and load it on your machine. But let's say that the customer wanted to make some changes to that model. We can always go back to AutoCAD, open up that part file, make any changes. Maybe let's just stretch this part a little bit. We want a bigger band on there maybe. Oop. Go ahead and save that. Close that file down, move back over to Inventor. I see now that I've got an update available. All I got to do is click the update. The model updates to that new geometry within inside of Inventor because we can see that it is still linked. And then all I have to do is come back into the CAM, regenerate that toolpath, and that is now going to update to that new length as well. Then the next process would be the post process.